Welcome to GEMA webinar. We are privileged to have among us Mr. Amarjeet Sharma and Dr. Rakesh Bhardwaj as the speakers from the industry. Mr. Amarjeet Sharma, Deputy General Manager, India Operations for Pertin Instruments, a Perkin-Elmer company. He carries more than 20 years of experience in implementation of rapid testing methods in agro-commodities-based businesses. Our second speaker is Dr. Rakesh Bhardwaj, ICAR NBPGR. His prime research interests are in food chemistry, NIR spectroscopy, and chemometrics. To his credit, he has about 170 research publications. I invite our knowledge partner to start knowledge share. Over to you, Mr. Amarjeet Sharma, sir.
Thank you, ma'am. I'm just sharing my slide. Can you confirm that it is visible to all?
Yes, sir. It is visible.
Yeah. So thank you, GEMA, for this opportunity given to present in front of all the esteemed colleagues and industry stalwarts here. So I think the topic is quite exciting for today's needs of the business, like rapid testing, which is one of the prime needs which is coming on in the business, looking into the kind of test what we need to do. So to introduce myself, I am Amarjeet Sharma, and I work in Pertin Instruments as a Deputy General Manager for India, and I look after the India operations for them. And I have worked with this kind of industry and this kind of products in rapid testing for more than 20 years now. So now, regarding the agenda, what we'll try to discuss, as you know, today we are two speakers over here. So I'm glad to have Dr. Rakesh Bhardwaj with me to talk more about the kind of technology, what it is. He will try to make you understand that how it works. Probably many of you also knows that what kind of technology it is, and then he will take it forward with his own research revelations, what he has found in his past research using this technology. So regarding Pertin also, I'd like to take some time a little bit to tell you that it's one of the very renowned company globally, and we are present in almost every country in direct form or with the help of distributors. In India, we are doing the operations by directly. We have our own service teams, we have our own application teams, and we have our own sales teams over here. So to talk about why these rapid testings are required. So basically, we have three instances at the businesses like upstream, midstream, and the downstream. Upstream is the area where we are actually procuring our raw materials. We need to know that the raw materials are as per our specs, and we are not paying for actually what we don't want. So, so we need to test over there, and we cannot depend on the testing methods which are taking quite a long time. So basically, NIR comes into play. There are different kind of instruments, models which are available, which can tell at the raw material intake, like what is the starch content over there, what is the moisture, be it in like maize or rice. So similarly, we need monitoring in the process also, that how the process is going on, whether the yields and recoveries are getting in the proper way or not, enzymes are working properly or not. So we need to test various parameters there. Again, we want it to be very fast. And finally, the co-products, that is the byproducts, we can say like DDGS and all that we would like to test. Now, what we want to achieve here? We want to achieve here the minimum time to react. That is, we want the results as fast as possible so that if required, we can take action on time. It should not be like I get results after 30 minutes, 45 minutes, 1 hour, and then by the time I know what is going on, it's already passed. So this rapid testings plays a very good role. How technically it is happening, Dr. Bhardwaj is really having done a very good research in it, so he will expose all those things over there. Now, when we use this kind of techniques, how we are benefited? We can use the results to reduce our operating costs, such as maybe enzymes. We can do some corrections. We can look for alternatives. We can try to implement in a better way. Energy consumption at dryers, like we can control the moisture properly with the process instruments. Then downtime and maintaining the transparency across. So anytime you do the test, you get the same kind of results. So we will be able to minimize the human error over there. Now, when we say different products at different points, like receivables, we want to pay for what we want to buy actually, what we want for the process. We can test immediately on mycotoxin kind of things, which is important here. We can monitor fermentation monitorings, like we have instruments which are based on benchtop techniques. We can control the process by process monitoring instruments. So at all the steps like raw material intake, production, final products, so we have different kind of instruments and models which are based on NIR spectrometry. Now, how that NIR spectrometry is working, we'll hear from Dr. Bhardwaj. Now, in 6 to 10 seconds, we can get those results ready on our screens. So like raw material, let it be corn, rice for moisture and starch. We have various in the process, yeast propagation, fermentation, broth, beer well, all these things, wet cake, DDGS. So all this can be tested very fast. Now, where we have implemented our solutions globally, like US and all are very mature in this biofuel terms. So the very big organizations like Valero, ICM Biofuels, Hunlake. So all these companies have associated with us for the testing needs, and we have implemented our solutions at various levels. Now, when I say like, what is the best battery what nature has created and which actually connected me with this kind of businesses and ethanol use of biomass to produce biofuel, say plants, they efficiently able to their store energy from the sun in the form of potential chemical energy. And the key today is that how much more we can extract by giving very less input, like to process the plant materials in such a way that the cost of the total energy input is less than the energy released. So this is what we want to achieve actually. We want to optimize the process. We want to get more closer to our readings. We want to reach repeatabilities, which want to have very less time to react. That is within very short time. We should have time to correct our process. So all these things will basically lead to less energy inputs, less cost, and getting out more than that. So not taking too much time because we'll be having some limitations. So I will now hand over my presentations to Dr. Bhardwaj. I think he will be able to tell you that how this technology works, what are the things which we can expect for, what we should not expect, and how the calibrations work. So this kind of more interior things, Dr. Bhardwaj will discuss with us. So Dr. Bhardwaj, I hand it over to you from here. You can share your decks. Thank you.
Thanks, Amarjeet, and thanks, GEMA, for giving me this opportunity to share some of my experience on this topic. So I hope the slides are visible.
Yes.
Yeah.
Yes, sir, it is visible.
Okay. Thank you. So there were a couple of difficulties initially on video aspect. Anyway, so I will be talking about how NIR spectroscopy can help in rapid testing for the quality traits. I can say with confidence in India, our lab is the leading one in the NIR spectroscopy. So considering because when I saw that gamma, so it is for grain ethanol, so I have tried to uh, keep my context related to it. So of course the raw material is the first starting step, and industry definitely want to know about the origin of the material, the quality of the material, purity of the material, and the safety of material. And all these aspects can be done very precisely by using the NIR spectroscopy techniques. Then farmers want immediate price nowadays. It's because it's a time of instant for everything. So farmers want right price at right and on time. So if the cost of analysis as well as the time of analysis is more, particularly time of analysis is more, then the farmer payments get delayed. So there also this technology can help that on the spot one can do the quality analysis and determine the price. And it is used also in India also. Then so that's what government as well as corporate sector both are ready to pay farmer, but once the quality is ensured. One cannot force that I should be paid MSP if the quality is not ensured. So is the processing industry requires real-time monitoring of the process as well as final product. And it requires rapid, accurate, and reliable methods, which will help ultimately in optimization of resource utilization. So what is the uniqueness of NIR technology? It is a multi-trade technique. So you can have the information for different trades in one go. Just scan the sample and you have the information of all the trades for which the calibrations are developed. It's not that you have to do chemistry for each and every trade. Once the spectra is taken and the calibrations are there, you have the information for all the trades for which the calibration is there. It is non-destructive, reliable, cost-effective, of course, environment savvy because you are not having hazardous chemicals. And less prone to error compared to wet chemistry when we have to do hundreds of sample, and when the time pressure is also high, there are chances of committing error in chemistry. But once we have developed the robust calibration, then the results from the NIR will be more reliable, more accurate than compared to the wet chemical analysis. So coming to the spectral region, if you think that near infrared, it is a region very close to the visible light. And different regions are used for different purposes, like X-ray is used for estimation of different minerals by the instrument XRF, X-ray fluorescence. Similarly, near infrared is used for the estimation of the biomolecules. And there is a reason for it. I will come to the reason why NIR is used for the estimation of biomolecules. But let's see, human eye has a spectral range of 400 to 700 nanometers. So what we can see? We can see dimensions, colors, surface features. So shape, size, texture, and other features we can see by our human eye. But after that, infrared region comes, which starts from 780 nanometer and spans up to 1000 micrometer. But near infrared region is from 780 nanometer to 2500 nanometer, and then mid infrared region is from 2500 nanometer to 50 micrometer. So these two regions have applicability with the biomolecules. But just the context that what is important in developing any relationships, whether it is with human beings or with molecules, is the frequency. When our frequency matches with someone, we become friends, we interact, we stretch with our friends, we dance with our friends. Exactly same thing happens with the biomolecules. The infrared region and mid-infrared region frequency is close to the molecular bond frequencies. So once these biomolecules get the infrared region, near infrared region wavelengths, and when their frequency matches, these bonds start stretching, twisting, bending, dancing, rotating. And in the process, they reveal the information about what the molecule is. So that's the basic crux that how near infrared helps in identifying and quantifying the different biomolecules. Here I'm giving you a very simple example. that was the work done in our laboratory, that the buckwheat flour, we commonly know as kuttu ka atta. So buckwheat flour, there are the two kind of major species in buckwheat in India. One is tartary buckwheat and another is common buckwheat. So that is a spectra, and you see all the spectra look like mixed together. And one will say that there is no difference between the tartary buckwheat flour spectra and common buckwheat flour spectra. But once we do the linear discriminant analysis, you can see that this is the beauty of NIR. I call it as a special eye, that what human eye cannot see, the special eye can see. And you can see that with 97% accuracy, it can distinguish between the common buckwheat flour and the tartary buckwheat flour. That's the beauty of this technology. So that's what I was saying. When the molecules get the frequencies close to their molecular bond frequency in the form of infrared light, then these cause stretching, bending, twisting, rotating, or we can say it's dancing with friends. So what are the different type of NIR spectroscopy solutions available? Near infrared, commonly known, that is the monochromator based, in which the rotating mirror grating is used to select the specific wavelength. FT-NIR, Fourier transform based, where there is a interferometer mirror is there which moves linearly forward and backward. Then acousto-optic tunable filter based systems are available. Besides NIR spectroscopy, even hyperspectral imaging is also used. Of course, hyperspectral imaging is costly, but it provides the information of different biomolecules distribution, spatial distribution. Now, this is the kind of spectra we get. You can see this kind of spectra is very sloppy. It is not giving much information. So one may feel disinterested by seeing this spectra. But this spectra carries a lot of information. And from how this information is coming, NIR spectra is formed due to the overtones and combinations because of the band stretching and bending and twisting. So infrared light, incident light sometimes loses some energy, sometimes gains some energy. So instead of, if you see here, it is not a straight line. It's having some information. But this changes have become because somewhere infrared light has gained the energy and somewhere it has lost energy, and it is influenced totally on the biochemical and molecular composition of the sample. Now, this molecular composition influences the spectra, and those facts are spread in the region and contributes to different wavelengths. Single molecule, if single target molecule, like for example, if I am targeting starch or if I am targeting sugar, then it will not be in a particular one wavelength. It will be spread in different regions and to a different wavelength. Each target molecule has different structure and functional groups. And that's how multiple wavelengths contribute to a single target molecule. So there is not a single wavelength relationship with the molecule, or let's say I identify one particular wavelength and that will be helpful to estimate the quantitation of starch. So it's not. There are different wavelengths contributing to the starch or to the sugar or to the protein. So and moreover, then the sample matrix also influence the NIR spectra. Whole grain spectra will be different. Flour spectra will be different. Broth or liquid or semi-solid spectra will be different. So calibrations are specific for trait as well as sample matrix. So for each kind of sample matrix and for specific trait, we are required to develop the calibrations. At ICAR and VPGR, we have worked on different crops across multiple traits. You can see it is a big list. In fact, in this also all crops and traits are not included. We have done much more than this. That's why I said that I can say with confidence that we are the leading one in the NIR spectroscopy chemometrics in India, for sure. There are some of the publications from our laboratory, not much of use now for this today's talk. Now coming to this, that how an NIR prediction modeling and chemometrics works, we can have three types. One is the quantitative one, where our target is to actually estimate the quantity of particular analyte, for example, starch, protein, sugar, even amino acids, specific amino acids, or specifically glucose or fructose or maltose or sucrose, any target molecule for which we are interested. We are not, we want to quantitate it in any kind of sample matrix. Uh, it has to be, it can be in the whole grain, it can be in the flour, or it will be in the broth. So, but what is required is the widest range of diversity should be available. Maximum variability should be available. And then another domain is where we are just simply clustering it, grouping the similar types. For example, say the grain comes for you, and then the grain you are keeping the silos for storage. Now you want to segregate the similar type of grains in different silos so that you can smoothen your process. And mind it, same variety can have different composition and different variety can also have the same composition. It depends on the agronomic practices being followed at the time of cultivation. Even the temperature, rainfall, fertilizer application, many things can influence. The same variety can have different composition and also the different varieties can have the same composition. Ideally, usually what we do in industry that we contact the farmer and say that this is the particular variety you have to grow and you have to grow by following these package of practices so that we get the consistent quality. But that also limits your choices. But we can let the grain come from any sector, but we can group them in the similar types. And then identification of two types, that is qualitative supervised learning. For example, I want to know the true GI. Yes, it is possible. So there are the different areas where these methods can be applied. For example, in raw materials could be from different crops. And you can see the multiple traits like moisture, starch, sugar, protein, phenol, beta glucan, aflatoxins. Yes, they can be quantitated. Similarly, when fermentation and other processes are going on, I can see what is the concentration of ethanol, glucose, maltose, whether lactic acid is forming, acetic acid is forming. All those things can be estimated. Similarly, the distiller grains, molasses, and final product ethanol. Yes, it is possible. Some examples of calibration in barley, corn, oats, you can see different traits like moisture, protein, starch, fiber, and the range of to which variability it covers. And you can see the correlations, 0.98, such a high correlation. So yes, we can estimate far better than wet chemistry does. Similarly for beer bottom, you can see, or for broth, yeah, and dried distiller. See how it's just see the dots on the x-axis and y-axis. X-axis is observed and y-axis is predicted, and you see such a good correlation is there between the actual laboratory value and the predicted value, which is also reflected in the R value 0.98, 0.91. So that gives the confidence that the predicted values are very, very true match of the laboratory value. In fact, in the final product like ethanol, if you are doing any analysis by gas chromatography, I can say with confidence you will get the result at par to the gas chromatography from the NIR spectroscopy, but with much less cost and in real time. Some examples where NIR spectroscopy, just outside the scope I am moving, that it can also be used to detect the adulterants like in turmeric. You can see it has been used and see the R square 0.99. So with very high accuracy, one can quantitate the adulterant. Similarly, in chili powder, these are two examples I took because these are the two most adulterated spices in India. So Sudan is used, Sudan dye is used, chili powder. Yes, can be. Now coming to key benefits of real-time decision making. If I am making decision in real time, then immediate action on quality issues one can take. Uh, One can reduce the waste. For example, when you are making first making this selection of raw material in real time, you can see whether the raw material is of appropriate quality, whether it is having the sufficient starch which I require, or is the moisture content too high. Otherwise, moisture content is too high, then the grain will start deteriorating quick. In the silos, I can check what is the situation of the grain which are stored in silos. Also, I can know the information about the grains in different silos, what is the quality of grain in different silos. Then when it is homogenized, flour, then what is the particle size of the flour? Then when it is boiled and then it is in the fermentation process, I can check in real time what is going on in the fermentation, what is the ethanol level, what is the lactic acid, acetic acid, and all. Even, for example, when we are making from barley, when we are making beer in the process, epihydrodendron is one compound which results in the formation of cyanogenic glycosides. And those cyanogenic glycosides are not shouldn't be there. So one can check what is the level of epihydrodendron in the initial stage itself in the grain. Similarly, so you are saving lot of cost involved in the wet chemistry, but most important, not just the cost in wet chemistry, but the time which is taken in wet chemistry, which delays my decisions, which is the, I will say, not although cost is also much less of analysis, but the time cost is most important here. So similarly, once the final product is there, then you in the co-product there could be starch remnant. To what extent the starch is there, that that will make me to think that why so much starch is not utilized. What is the problem with the raw material, or is there a problem in the process of fermentation? Is there any process of quality of yeast I have used? So one can definitely find that from the raw material. Then also the also the co-product or byproduct. When we are selling the co-product or byproduct, we can sell it based on the quality of that. How much is the starch is there? How much is the protein is there? Now protein market is growing very fast. With so much protein isolates are available in market. Protein bars are available in market. Now the co-product is now equating equal to the product because the leftover is rich in protein. Now, uh, I need to price that also based on the quality. So, NS spectroscopy enhances the transparency and efficiency in complete value chain, starting from raw material to the process to the final products as and co-products. So it helps in process monitoring, authenticity verification, and most importantly, again, integration with digital tools. You can have the information directly on your mobile phone. If you are a quality manager, you can have it on your computers or as well as on your mobile phones. See what is happening at which stage and immediately, and all results are in real time, so immediately you can intervene. So it also helps in safety in the process as well as safety with raw material if the material is having some toxins, or the final product. So that's how it helps in reducing the cost as well as environmental sustainability. So that's what I wanted to share in brief. I was told much time is not there. Otherwise, this topic can be a really interesting one. I welcome your questions.
Sir, what is the cost of this machine?
Sir, cost, I won't be, I'm from academia, so that the industry partner can tell you. But depends on the configurations. And initial cost, you may feel bit high. but the running cost is really very, very low.
Dr.
See, can we
Bhardwaj,
do the can we do the all parameter analysis with one machine, or the different machine will be required for different
Uh,
machine will be required for the different test? Like the
I can tell
we
you,
are
yeah.
we are
Yeah, I
doing a
can
lot of
answer that.
analysis on the different stages.
Yeah,
So at every stage, do we require with single machine or the different?
I'm answering it. I'm answering it.
Yeah.
See, if the setup is small, so you will not be going for real-time monitoring. So you can go for sampling, and single machine can do. You can take the sample from the raw material. You can take the sample from flour. You can take the sample from broth. You can take the sample from fermenter, and you can take the sample from final product. And use a single machine, but it will not provide you the real-time monitoring. But you have to draw the sample, and then once you put it in the machine, you scan it, you will get the result at that moment. But if the setup is big, I will suggest you can have online. So at every place you have to place the instrument. But you will be getting every time for continuous result.
Because actually, suppose we are having the a lab setup,
Yeah.
and in the lab setup, suppose we are sampling, we are doing the sampling from the grain size, we are doing the sampling from the mail after mailing, we are doing the sampling after the liquefaction, then we are doing the sampling from the fermenter. Suppose I need to know the VA, volatile acids in the fermenter. So, what is that? And based on the VA, we can take the further action for the better
Yes.
results of the fermentation.
Yes.
So
Yes.
that's why we want to know each and every parameter
Yes.
at every stage.
Yes. Single instrument also you can use it.
Yes,
The thing will be every time you will be bringing the sample the way you are bringing the sample to the lab now. You have to bring the sample to the lab, but instead of doing chemistry, you will simply do the scanning for each sample
okay.
from each stage.
But we have to use this different sampler, no, sir. It will be dry sample will be different, liquid sample will be different, correct?
Different accessories will be there.
Yeah, it will
Different
be
for
very.
liquid
So
sample.
for,
In the
what
single
about
instrument, you can have an accessory for liquid sample. You can have sample accessory for the grain sample or the dry sample or the moist sample also. There will be different accessories, but single instrument can work that.
it will be reflected in the dry method or wet method, the starch moisture content. It will be showing, I think without grinding, it will show wet method, right? Wet starch content and all.
No, see, as far as my experience, I will tell that we have developed the calibration for whole grain.
Mm.
We have developed the calibrations for flour. I am not working on alcohol.
Okay.
I am working at National Bureau of Plant Genetic Resources at Pusa, New Delhi. So we have lot of diversity in different crops. For example, in rice, we have nearly 1 lakh type of rice, which are not only from India, from other countries also. Similarly, in wheat, we have around 30,000 different kinds of wheat. In barley, around 8,000 different kinds of barley. So my job is to do the chemical analysis, and I know for thousands of sample, wet chemistry will not work. So for that reason, I have developed calibrations for different food crop metrics, and we have developed metrics for whole grain as well as for flour. So it will work for whole grain, it will work for flour. I am not working on liquid sample, but it will work for liquid sample also. We need to develop the calibration. Industry can have their own calibration. Perkin Elmer will be having their own calibration package.
Our ethanol industry having the only focused on maize and rice. So no need wide infra red regions. So it's possible because of that will be cost is around more than double the
No.
price of the.
See,
It is how to optimize.
let me tell you. See, when the near infrared region or spectrum range is required for different biomolecules, not for the crops. Different biomolecules require different wavelength. Now, if you are targeting only one or two parameter, for example, if you are targeting only moisture, oil, and protein, which is the case with the oilseed market, like in mandis. In Rajasthan, if you go, in Rajasthan, Gujarat, if you go, then in the mandis they have kept these NIR spectrometers. So farmer come with the sample, mustard sample, they will put it and see the moisture and oil content, and based on that they will pay the price. Now those instruments are not very costly because they have
Yes.
to detect only moisture and oil. But in your industry, I see there's a lot of parameter which are important. So you definitely require wider spectrum of NIR. Narrow
But
spectrum will not work for you
so
because
that will be, suppose I am looking for certain parameter only. There is no deviation in the accuracy. Either suppose I go for only three parameter, starch and moisture, I can go for only lowest cost
yeah, you can go
equipment.
for lowest cost, but then see, but you are not. Then your effort will be reduced only for those two parameter.
Okay.
You can avoid the chemistry for only for those two parameter. Moreover, at this stage, industry is focusing only on the starch quantity, right? You are looking how much starch is there in the rice or in the wheat or the corn. But how about rapidly fermentable starch? Industry is not looking on that. But see, if the fermentation time is more, it's not only increasing the duration cost, it is also increasing the risk of more lactic acid, more acetic acid, as well as more methanol. And also the more chances of aflatoxin or epihydrodendron induced cyanogenic glycosides in the barley beer production.
Yes, we discussed with the many suppliers also NIR method. They're having experience in here solids analysis. They're not experienced in the not present to us the liquid analysis, especially as you told in the ethanol and in the fermentation and conversions. We are also waiting to see the results. If we
I
can, we
mean,
can.
in liquids also it is possible. I have done recently, I was working for some other purpose. I was looking for standardizing the method of sugars and oligosaccharide to get result at par with HPLC. So I was so what we did, we prepared the standard solutions of glucose, fructose, sucrose, maltose, then raffinose, stachyose, the oligosaccharide. We analyzed on HPLC. It was a liquid solution, and also on NIR, and works beautifully.
This aflatoxin you mentioning you can view in the checking the NIR method. How much it will be? Is it accurate one? Normally we do
See,
HPLC
that
method.
I have not estimated the aflatoxin, but I checked in the literature. There are publications where NIR is used for measuring the aflatoxin.
Mm.
So, of course, your concern is genuine because aflatoxin will be in a very small quantity,
Mm.
and it is important concern, health concern. So, but yes, in literature it is there. I have not done
Uh,
it.
so how much time radial calibration is the very important for this NIR
Yeah,
method? How
calibration is
much
the most important
frequency
step.
can you update in the periodically online you do it or we have to do the for the calibration? Is a
See,
big issue for because we are procuring
yeah,
the raw material.
I will suggest the industry from which you will be taking the instrument. They should provide the calibration support, or they can engage someone to provide that calibration support, because calibration, with my experience on chemometrics, I know that it is not so easy. It requires a lot of, in fact, one has to fall in love with these spectras to understand the psychology of computer also. I have not yet revealed because my research publication is under the communication stage. There is one phenomenon called shrinkage in NIR spectroscopy. And I have discussed with many chemometricians because I found out the way out of it. So that shrinkage is what? That the highest as well as lowest value. So highest value it will give slightly low, and lowest value it will give slightly high. That is called shrinkage. And we have developed the models where there is no shrinkage, rather they can even extrapolate and interpolate. If I have made the calibration model, let's say from 10% to 20%, it can also estimate 25% value. I have overcome that with because I could understand the psychology of the computer. So
We
I
are receiving
cannot
the raw
reveal that what
material.
is the strategy by which we have overcome. But right now in world, people are not aware how to. Once my publication comes out, then the people will understand what is that.
Because our raw material coming from different regions, we don't know where it is coming.
Yeah. So even geographical origin, that's another thing, because you can find plenty of publications where NIR spectroscopy is used to identify the true GI, because GI get the special price. If like for example, Dehraduni basmati in North India, we know that is considered best. But am I getting the Dehraduni basmati which is cultivated in the Dehradun region area, or it was cultivated nearby Meerut? Same variety. But the same variety cultivated in different environments will have different composition. So by use of NIR spectroscopy, we can identify the geographical origin also. So if the industry is interested only, we want only this variety, we will not want to have different varieties, okay, and also cultivate in this area with this package of practices. Then if some supplier providing you the produce from other region or a similar variety, you can, with clear cut, you can identify by NIR. There are plenty of publications where NIR is used to distinguish true geographic indicators. Even in the honey also, the different floral origin honey, or is the for and also for checking adulteration in different spices, as I showed you some example in saffron. Nowadays saffron is also cultivated in Delhi in AC rooms, some people are doing saffron cultivation in Delhi in their AC room. They are
Dr.
doing it with proper light arrangement, but
Dr.
still the
Bhardwaj.
quality will not be the same as that of the one saffron from Kashmir. Can I distinguish it? Both are true saffron, but yes, I can distinguish it.
Dr. Bhardwaj,
Yeah.
thanks a lot for uh, revealing concepts of the raw material identification. I'd like to take you back to the subject relevant to us,
Yeah.
where you had talked about chemometrics for sugar profiles.
Yeah.
There was a slide that you discussed on chemometrics, and that is discovering glycerol and sugar profile DP1, 2, 3, 4, so on. And you also mentioned in your Q&A that this would be a close substitute to HPLC.
Yeah. Yes.
Yeah. So I'd like to hear a little bit more about this for you to talk a little bit more, because this is still an untapped area for our industry and for myself. So kindly,
Yeah.
please spend
Thanks
some
for
more
bringing me
time.
back. Being
Yeah.
a academician, there are chances for us to deviate. Anyway,
No, never
yeah,
mind, never mind.
yeah. The
Hmm.
thing is that when we are working on raw material like whole grain or flour, there is a
Hmm.
sample matrix in it.
Hmm.
The sample matrix influences the spectra.
Hmm.
But when I am talking of filtrate, when I'm talking of final product as ethanol, or when I have taken the extract out from the sample matrix, let's say ethanol extract or water extract. So sample matrices has been eliminated. That what we do even when we are doing the chemistry. If I want to estimate the starch and sugar in the sample, I will extract out the starch or I will extract out the sugar and then add my reagents and estimate it. Right? So further, once I have taken out the extract, I have eliminated the sample matrix. So the interference from the sample matrix is eliminated. After that, when I get the results, then those results come at par to the gas chromatography or liquid chromatography. For example, if I am working on volatiles, like if you want to see methanol and ethanol, you will be estimating through gas chromatography, right? Because
Yes,
it's volatile.
correct. That is alcohols. I'm
Yeah,
talking
alcohol.
sugar profile.
If you are estimating methanol and ethanol, you will be most probably doing by gas chromatography,
Correct. That's the
right?
finished product
Yeah,
and
yeah.
yeah. And how about the sugar profile?
Sugar profile one can do on gas chromatography also, and on liquid chromatography also. In gas chromatography, you have to derivize the sugars for doing on GC, but you can do directly on liquid chromatography, HPLC. So sugar profile I have done in my lab also for glucose, fructose, sucrose, maltose, and oligosaccharide raffinose, stachyose. The results were at par with the liquid chromatography.
Okay. Okay. Thank you.
And the simple reason is sample matrix is not there. It's simply the extract.
Okay. Any more questions in the forum?
Good evening, Rakesh ji.
Yeah.
So I've been using NIR, the spectrophotometer, since last 8 months, and you know, we couldn't calibrate it till date. So we've been doing it for the last 8 months. When we commissioned our plant, at that moment only we bought the NIR, and for grain we've calibrated thousands of samples. And now I think we are in a position where we can say that grain samples are calibrated, but for the sugar profile, like Arushi ji said, it's been 8 months, but we are not able to calibrate it to the extent that we want. So how do you recommend we calibrate it? Because doing thousands of samples in an HPLC and then putting that data in the NIR and then expecting the result to the level of accuracy that we want. So we are running out of patience. So how do you recommend, like, what do we do with it?
Akshat, what is the requirement for calibration is not the number of samples. Of course, we require good number of sample. But what is the most important thing is the diversity of the sample, the range of variation in the sample. It's just like, that's what I was saying, understanding the psychology. If I am teaching my kid ABCD from the printed text all the time, and suddenly for the test, I give the poorly written hand note, my kid may fail because the kid has understood it from the printed text only. Correct? So same way, if we provide the huge diversity of this sample matrix, calibrations come very nice and they work very nice. And that's what the advantage at NBPGR we have, as I told, that we have the material collected not only from India but also imported from different countries. That's because that is our responsibility as a custodian of genetic material. So the calibrations which we make, they are robust, cover widest possible ranges. For example, in wheat, we have sample with protein content ranging from 7% to 20% protein.
Okay.
Okay. So that's one example. Similarly, in starch, it will be having very wide range. So the system will learn from minimum to maximum. And it will be able to distinguish, just like worst handwriting to the best handwriting.
Okay. So we'll have to do, get more samples of a wide
That was
range
kind of
and keep
sample. The thing is
calibrating.
that the sample which you are getting, they are the market sample, I will say, because these are the sample which are on the popular varieties which are cultivated.
Yeah.
And the popular varieties are having a composition in a very narrow range. They are not diverse.
Sorry, I'm not able to understand. Shreyans
Yeah.
has a valid point because he's raising samples, the company is raising samples of its own sugar profile.
Yeah.
Shreyans, आप यही कर रहे हैं ना?
Hmm.
So now, what is your point? I don't
My
understand.
point
What
is that,
diversity, what kind of a diversity are you looking for?
for example, in the sugar profile, glucose, fructose, sucrose, maltose, right? So there will be samples with very low glucose or very low fructose with very low sucrose or the very high content of them. So, but the samples which they receive, they will be, of course, from the market or from the farmers, and those will be of the popular varieties which are being cultivated. And those popular varieties which are cultivated, they will have a very narrow range of variation. The concentration of glucose, fructose, sucrose will be in the very narrow range. for making a very good calibration, you need the diversity. You need a wider possible ranges. Let's say, if I'm talking of just for the sake of saying, sample, let's say glucose is 0.5 to 1.5% in the market sample. But if I am having a kind of material which is having, let's say, from 0.2% to 3%, is a wider range. So system will learn more efficiently.
Okay.
That's what I was saying. Bad handwriting is also important for us to know, to learn.
Okay, thank you. Did that bring any clarity to you?
Some extent, but I think it's still very tough to calibrate this machine for
Is
all
that
the
right?
sugar profiles.
Yeah,
Because,
it is difficult to
yeah.
calibrate, but once you have the more variability, you will find it is easy to calibrate.
Okay.
That is a strange observation. But anyhow, yeah, we'll try better. As an industry, we'll learn.
Yeah.
Any more questions?
Industry learn much faster.
Because we are practical, we are practicing every moment. Yeah.
Good evening, sir. Myself Sunil Yadav from Mangala.
Yeah.
Sir, is any development is going on in handy and portable equipment for this such kind of inspection and all activities?
There are different kind of instruments available. Uh, uh, See,
As industry have
earlier there was only the
rapid
portable, earlier there were only the benchtop kind of instruments. Now there are online instruments for different kind of application, for liquid sample, for solid sample, or for putting on the conveyor belt, for putting in the silos. There are different kind of instruments available. Even the handheld
because
instrument, for example, if you are going to mandi to procure the sample and to finalize which lot I have to purchase, you can have the handheld instrument also. Just that handheld instrument you can carry is very handy, and just put in and take the spectra, and you will on that spot also you can identify this material is good for me.
because it is need of time ki lot of sampling is going on in the plants. So we
Yeah.
require we should take frequent samples from each and
So
every
that's what I was saying, that in the first question they asked that whether single instrument will work. Yes, single instrument will work, but then you have to bring the sample all the time. But if you have a small plant, it is good. But if the plant is big, capacity is high, then I will suggest that you should have place multiple instrument at different locations online. So you don't have to do sampling. You are getting the result from each and every point where you have put the instrument.
While taking sample from lorry truck to truck, it took
While taking sample from lorry truck, you can prefer handheld instrument.
Yes,
In
yes. For
fact,
the
we are planning to work on NIR spoon also.
okay.
So in the spoon, there will be the detectors and the sensors and the LED diodes for specific wavelength. But NIR spoon will work for maybe 2 or 3 parameters, 4 parameters, because capacity will be low. So
Yes.
the most important trait, which is one, we can develop even the NIR spoon also. But funding is always remain the concern for us.
Or if you
But
can look it in this particular dimension, because it is a wide spectrum.
yeah.
If anything comes very handy and very portable, it will be remarkable for the industry.
So one thing is that at initial stage, what you can do, you can purchase. There are the numerous handheld NIR instrument also, and then you can get them calibrated. Okay. And then once they are calibrated, you can use them. You just carry them with you in the market, and on the spot you have the result. You don't have to come back to lab. There itself
Yes.
you can decide.
Okay, sir. Thank you.
Any other questions from the member side?
Good afternoon. Good evening, Dr. Bhardwaj. How are you?
I'm fine. Fantastic.
Thank you. It was a very nice presentation. A lot of learning about the technology. I'm having one small query.
Yeah.
Suppose I'm having one instrument for the benchtop.
Hmm.
Can the data from that instrument can be used in other new instruments to making that calibration?
Provided similar configuration is there in both the instrument.
Yes. Suppose I'm having in one unit, there is one instrument which is getting similar kind of raw material, maize and rice and everything. And in another unit, I want to purchase one more, and that can be calibrated based on the data which I'm having earlier. That is possible?
Provided, is it FT-NIR or NIR?
I have to check. I have to check. I think it is NIR only, not the FTINR.
That has to be checked, or there are some methods to convert NIR spectra to FT spectra also. There are some
Great,
methods
great,
available.
great.
But still, I will say that to acquire the spectra fresh also, initially you can use it as a to establish training criteria. But later on, once you acquire the spectra, because once you have installed it, you will be definitely getting the spectra continuously.
Exactly, exactly. That will
Then later
add
on,
on to the data.
you can have the robust calibration for that instrument.
Great. And my follow-up question is, if we would like to buy the online NIR system for the DS or for the protein or the starch content in the inline system in the ethanol industry, how frequently do you have to clean those sensors and all? Because that is a major challenge. That's why this automation is not been achieved.
So that information, I think Amarjit will be the more appropriate person to answer it because he is from industry. I am from academia. I don't use them.
Okay.
I've only seen them, not used them.
Sir, I can just add on onto this to sir's question. So, sir, this process and all we have experience of implementing into various industries. So basically cleaning and all, if you're saying like, dust gathering and all on the sensors. So that will not happen because that instrument has been designed like that. So instrument has been designed to be at a high moisture area to bear the high temperature. Suppose you put it near to the dryer, okay? So then the area that maybe sample temperature is high, ambient temperature is high at that particular position. So the instrument is able to take all that. Suppose in the process, if it is getting some dust between the source and the sample, okay, so there is a gap. So it is able to, by purging air and this kind of mechanisms, it is able to handle all that. So the instruments are able to handle. If you want, I can share you some more details, some more case studies that how it has been done abroad in other ethanol industries in US and all, how they have tried to implement this. So we can discuss, sir.
Because I think the common problem or unified problem for the ethanol industry is how much DS is in the system. One of the common problem. We have to back calculate the exact DS. There are no hard and fast. It's difficult to calculate even with the payment system installed. The DS is a challenge of the industry. It's a big challenge for the industry.
Yeah.
Sure.
Yeah.
Yes.
So
Thank you,
real time,
Majid, for
Thank you,
real
sir.
time with the NIR, you can have the results. And in fact, at the raw material itself, you can identify which material is best for me.
yes,
Not only the
yes, yes,
starch
yes.
content, but also the starch quality.
Great, great. I want to shed one light also, just the anecdote. The एम्स डॉक्टर के पास सैंपल साइज इतना वेरिड होता है एम्स के डॉक्टर्स के पास दैट्स व्हाई दे आर सो सक्सेसफुल एंड द सेम क्राइटेरिया अप्लाइज हियर कि वो जो सैंपल का वेरिएशन makes them more experience, machine more experience, so that they can give the right result.
Yes, that's what the point I was saying. The more the variation, machine learns much better.
Understood. Yes. Thank you. Thank you. Thank you, Mr. Bhardwaj. Thank you, Amarjit ji.
Thank you, sir. Thank you very much.
Sir, and what will be the frequency for the calibration of machine?
Calibration once done, they work for years, but one can still update them.
Okay, okay.
Yeah, but once calibration is done, it works for years.
So work for year. Okay, okay. Thank you.
Provided your instrument is also working with same efficiency. Otherwise, some bias may come.
Yeah. Thank you, sir.
Any other questions?
Yes,
So,
ma'am.
Yeah.
My question is, sir, can I check TFM broken rice in this instrument?
Broken rice.
Yes, sir.
Yes,
TFM.
because if we can check the particle size of the flour, then we can
Okay.
also check the broken rice or insect infested rice. Yes.
Okay, sir.
any other question? Since there is no more questions from the members, let us conclude the webinar.
Right.
So,
Thank you. Thank you, everyone.
Thank you.
we are very thankful to Mr. Amarjeet sir and Dr. Rakesh Bhardwaj as the valuable knowledge partner. Please accept a token of appreciation from GEMA.
Thank you.
Thank you. Thank you very much.
This will be sent to you by mail also, sir. Thank
Thank
you
you, ma'am.
once again.
Thank you, ma'am. We are
Thank you
privileged to
all.
have this, ma'am. Thank you.
Thank you all for your valuable time and participation.
Yeah,
Thank you.
bye.
Thank you.